Kia ora Year 12 and 13. This is the first video on optimisation. I'm going to just do one question on this, and I promise I'm going to try and keep it short. So this first problem is a classic optimisation one. You'll find it in just about every calculus book in one version or another. So a farmer has been given 300 metres of fencing wire. This is the only fencing wire she can get in New Zealand. There's no more for sale, and she has to do something about her sheep. Shall we draw a picture of a sheep? All right, here's a sheep. Okay, so the sheep are running crazy. She needs to use her fencing wire, and she wants to build as big a paddock as she can. So the fence that she builds is going to fence off some kind of rectangle. Your mission is to work out the dimensions of the paddock, assuming that it's rectangular. Okay, so I want you to have a go at that problem without me giving you any hints, and then hit continue on the video when you've given it a try. Okay, well, I'm hoping the first thing you did is to draw a picture, because that is, as you know from class, how we should always start off. So we're going to define our variables, all right? So let x be the length of the paddock, and let y be the width, and we'll let a be the area. So a is going to equal x times y. Okay, sorry about the messy handwriting, but you get the idea. Right, so that's the first step. So we've defined the variables, we've drawn the picture, and we've worked out what a is, and this is what we want to maximise. Okay, so the next step is to work out what is the constraint, in other words, the kind of limitation that I have from the fencing wire. Right, so the constraint is that the perimeter, which is 2x plus 2y, can't be more than 300 metres. Now, when we're doing level 3, we're almost always going to be working with an equality here. Right, so of course we could have some of the fencing wire left over, but that would be stupid because she wants to build the biggest possible, that the paddock has to be as big as possible. Okay, so she will want to be using up all 300 metres, that's why we'll write an equals sign there. So if we work with this, remember we've got a is equal to xy. We want to maximise a, and we know we're going to do that by differentiating. However, in here we've got two variables, we've got x and we've got y. So we're going to try and eliminate one of those, and we'll do that by writing 2y is equal to 300 minus 2x, or y is equal to 150 minus x. Now if we substitute that back in, we get a equals x times 150 minus x. And we're going to want to differentiate that, so we might as well expand that out right now. So 150x minus x squared. So now what we've got is an expression for the area of the paddock, just in terms of the length of the field, that takes account of the fact that we've just got 300 metres of wire. So we want to maximise that function. Right, so to maximise, we're going to need to find where the derivative is equal to 0. And then we're going to check that the second derivative is negative, right? So that's my second derivative test. Right, so dA by dx is equal to 150 minus 2x. We want to make that equal to 0, so we're going to get 2x equals 150, x is equal to 75 metres. Now, we had how much fencing wire? Let's see. We had 300 metres of fencing wire, so we're going to substitute back in to work out what y is. Remember, y was 150 minus x, which is also going to equal 75 metres. So it looks like having the side lengths be the same is going to maximise the field here, but I still need to check that I've indeed found a maximum. So we had dA by dx is equal to 150 minus 2x, and the second derivative is equal to negative 2, which is negative, so we have found a maximum. Right, I just want to go over one thing about rectangular areas on the next slide. So what we've found here is that the dimensions of the paddock should be 75 metres in length and width. Right. Now, one thing that my Year 12s in doing 12 MAT always say to me is that, hang on, miss, that is not a rectangle, that is a very badly drawn square. Right, so I want you just to remember Venn diagrams. In here we've got squares, and out here we've got rectangles. So the definition of a rectangle is something that has 4 right angles and 2 pairs of parallel sides. Okay, they don't have to be of unequal length. So even though you want to call that a square, and it is a square, it's also a rectangle. Right, that's the first problem. I'm going to try and do a few more now. So make sure you've got that one down pat, and they will slowly get a bit harder. Thanks for watching.